Greetings, everyone, and welcome to the Complexity Lounge, a meetup where we gather to talk about all things related to complexity and complex adaptive systems. My name is Jaka Selberg, and somewhere out there in our NYC apartment is the uber talented Barbara Frontera, and together we co-host the lounge. Before we kick it off, just a few ground rules. We will be recording today's session, so if you do not wish to be recorded, please make sure your camera and microphone are turned off. We also ask that you please keep the side chat activity to a minimum during the presentation. After Michael's talk, we'll have a question and answer period and hopefully a nice conversation with you all that are joining us today. And you can either raise your hand or just send your questions directly to Barbara with a big Q in front via the chat so that she knows that it's a question and not a comment. The recording will be posted on our Vimeo Complexity Lounge page in the next couple of days, and that is where you will find all of our past videos from the lounge. Our guest today is Michael Feathers. Michael is the founder and director of R7K Research and Conveyance and the chief architect at Globant. He is also the author of the book, Working Effectively with Legacy Code. Today, Michael will be discussing what he refers to as forms, that is, domain-independent abstractions, which he posits are patterns that can be found across more than one domain, helping us to identify structures that we might otherwise miss. So, Michael, welcome to the lounge.
No, thank you very much. It's great to be here. And I always enjoy basically going and talking with people who are really, really deeply interested in complexity and various other topics like that. I guess I have to kind of like apologize a little bit first because this isn't really directly about complexity, but it's really about something which is at an equally high level of abstraction and something I've been thinking about for years actually, and have only recently tried to go and talk to people about. And I think the thing that makes it a little bit difficult is that it's dealing with things that are rather high level of generality, and some might say it's actually too general. But let me go and sort of like, segue into this by going and giving a bit of an example, okay? So there's this interesting thing in software development, which is the field that I come from, this problem that basically occurred very early on in the development of the internet. And it was really to have best give guidance to people who are developing applications that could communicate with each other across networks. And an interesting thing with this was that there was a piece of advice that came out that was known as Postel's law. And I'm giving you a bunch of text here. This is probably the most text you'll see in this entire presentation. But Postel's law was basically something that was formulated by a guy named John Postel. He was an early pioneer of the internet. And he was basically trying to go and codify into a single maxim this idea that basically helps when you're structuring systems. He said, basically, if you have components in a network and you're stringing them together such that one goes and sends information to another, it's good to be very liberal in what you accept and very conservative in what you send, okay? So if you receive things that look like they're malformed or errors, just sort of like take that in stride, try to figure out the best intention of the data that's coming in, and don't just sort of block it and say, okay, we can't accept that at all. Instead, try to do something with it. But be very, very careful about what you put into the network yourself. You should be absolutely sure that what you're putting in the network is valuable and well-formed and good. And if you do this sort of thing, and if everybody does this kind of thing, then you end up with a system that tends to basically sort of like work together very well. Now, this is kind of a fascinating thing. And I remember reading about this early in my career and kind of like putting it into practice. And it's interesting because it's rather general in the sense that you can basically go and apply this between pieces that are communicating across a network, but you can also apply this in systems design. Some of you may know of like HTML, which is the language that basically the web kind of runs on in a sense. And one of the interesting things that happened with internet browsers in the early days was that many of them were in competition with each other. And they basically all kind of adopted Postel's law to go and sort of like be a little bit better than the other browsers, such to the point where basically anything that sort of smelled like HTML would be renderable by the browser without it going and saying, there's a big error here, I can't go and display this web page to you. So you end up in this place now where basically some browser rendering code that renders the HTML is some of the most complicated code on the planet, because essentially it's trying to go and make sense of things that could possibly be malformed. And then when it does this, go and render them and show them to us. Now, you might look at this and say, gee whiz, Mike, you're going and talking about something very technical here. And, I hope this entire talk isn't like that. But The thing about this is that there's some interesting aspects to this that basically kind of play off in other domains besides software as well. Since the beginning of the internet, some people have said that this is basically a rather harmful law. And the reason why is because once you kind of open the door to go and say, anybody can put anything malformed in the system, you're just going to go and work with it, you actually go ahead and sort of like introduce possible security problems. People could put malformed inputs in a system just to actually sort of hack into the system. And it ends up becoming a bit of a security nightmare. Now, here's the thing that's interesting about this. There's an analog to Postel's law that was first articulated by a guy named Larry Wall. And he was like the developer of a language called Perl. And he basically said that this law kind of sort of fits in the context of social situations as well. So imagine you go to a party, and at that party, it's kind of like, you know, somebody starts talking about sports, for instance, and the person next to you is going and saying, oh, my team is the best team ever, and talking all sorts of stuff about how great this team happens to be. You have a choice at that moment of being confrontational and saying, no, it isn't really the best team, and then going and making the case for your team, or you can kind of listen quietly, but just be very careful that you're polite in the conversation. Isn't this kind of Postel's law in a way also, right? You're being very tolerant of input, but you're being very careful about what you put yourself into the conversation. And the thing that I mentioned in the networking example, where you have pieces of software that communicate with each other, the idea is to go and basically grow a system through composition that basically works together well in harmony. And you can basically be in the same situation in a party, for instance. If everybody's kind of like doing this thing of like just tolerating things a little bit outside of the range of what they might normally tolerate, but being very careful about what they put in, then you might have a very harmonious, you know, get together in a way. Now, in social systems, there's an analog to the security breach thing that we talked about a little bit earlier with Postel's law, and that's kind of known as Popper's paradox, Karl Popper. He basically talked about tolerant societies having this possibility of malevolent action, where essentially you say, for instance, I will be tolerant of anything, but I will even be tolerant of intolerance. And if you're tolerant of intolerance, then you can actually be in a situation where you actually sort of undermine democracy and good social order and stuff along those lines. Now, it's kind of fascinating about this that essentially here we have something that basically applies to networks, and then it also applies to social systems, technological systems as well as social systems. And I find that utterly fascinating. And when you see this kind of thing, it's quite often this interesting hunt to go and basically see if you can find other things that really align in the same way. And so as a background task, I've been collecting these things. Here's another one. These are a bunch of PVC pipes that are basically used for carrying fluids from one direction to another. And one of the things you'll notice about them is that they have like a flanged end, right, that's wider on one end than on the other. And the reason why is because if you have that, you can kind of like piece them together one after another, and essentially they all kind of connect because you have an open flange and you have the narrow flange that kind of fits into it. And, you know, you can basically sort of see the same dynamic with funnels, right? If you have funnels and they are wide at one end and narrow at another, chances are things are going to kind of like compose together harmoniously, and you'll have very little spillage of water or whatever fluid you're basically passing through them. Now, here's the thing that's very, very interesting about this is that usually when people talk about things like this, they say, okay, well, it looks like you're using funnels as a metaphor for Postel's law and technical systems, right? But I could also go ahead and flip it around and say maybe Postel's law is a metaphor for funnels. And maybe the social party dynamic is a metaphor for funnels, and maybe funnels is a metaphor for the party dynamic that I mentioned a little bit earlier. What's what here, right? Now, I find this fascinating because I'll give you two other examples, then we'll get into this thing of what's a metaphor for what. At a gas station a couple of months ago, I basically saw this particular piece of advice, or not advice, but as a warning on the gas station pump about regulatory authority and such. And it basically said this device must not cause harmful interference, talking about radio and electrical interference. It must accept any interference received, including interference that may cause undesired operation. Is that the same as Postel's law? Yeah, I think so. Now let's go even further. Okay, this is a quote from an ancient Stoic philosopher, Marcus Aurelius. Be tolerant with others and strict with yourself. Okay, so it's kind of like you are basically going to be accepting of input, but then be very careful about what you do internally in terms of like maintaining yourself. These to me all seem to be the same thing. And it's kind of fascinating that we have this same pattern that goes and occurs in many different places. a while back, I was basically talking to somebody about this on Twitter, and one of the things that this guy pointed out to me was that if you look at category theory, which is a branch of mathematics, there's something called a profunctor, which basically describes mathematically this relationship of compositionality of mappings between things. And so, yeah, kind of fascinating to go and recognize that that sort of thing exists mathematically. But I think it's kind of fascinating as well to go and notice that this is a general systems principle. It's something which can be done in systems. It's some people can say this is harmful in certain circumstances or that it is beneficial. But I think the interesting thing is that it's very much like, say, gravity, for instance, in the sense that you can argue whether gravity is a good idea or a bad idea, but still it is something which is has repeatable dynamics within systems. So the thing I was kind of wondering about with this, as I started looking around for other things like this, is, are there, I guess, other things like this that tend to work cross-domain, structuring principles? And when you have those, what actually do you do with them? It's interesting because the quite often they have names in particular domains, like Postel's law. If I start talking about that, nobody would know what I was talking about if I started talking about things in social science, for instance. It's kind of an awkward thing that we have these general principles, but we don't really have names that stretch across various different domains. So part of what I've been looking at is trying to go and find these particular things, articulate them, throw them in front of people, and then maybe make up names to go and describe some of these things. So the one that I use for Postel's law, I just kind of call it Lavin. I think I had that in an earlier slide. It's just a made up name that goes and describes this particular principle just so that it can facilitate conversation to some degree. Anybody ever hear of this guy here, George Lakoff? He wrote a wonderful series of books about metaphor many years ago. And he makes the case that just about everything about reasoning is metaphorical. And, his case is very interesting and very good. I think that it misses something, though, and I'm going to get into that in a minute. That this relationship that we can have sometimes when we're looking at something and saying that it's a metaphor for another thing, it looks kind of like this to me. If we can say that A is a metaphor for B and that B is a metaphor for A, then what it could be doing is it could be implying a third thing for us. It could be implying some form, which is what I call these things, where it's some kind of behavioral structural abstraction that can be manifested itself in, it can manifest itself in many different domains. And if you're aware of some of these things, then you might go and sort of like see unique opportunities to apply solutions in perhaps the social domain that you find in the technical domain, or in in a technical domain that you basically see in biology, for instance, or in the conceptual domain that you basically see in other realms as well. So it's been a bit of a hunt for these kinds of things and trying to go and sort of understand what they are and deal with it. I feel a bit awkward when I talk about these things because these things are, very abstract, and I don't really want to go and make any strong statement of what their reality happens to be. It could be the case, like George Lakoff mentioned earlier, that all this is metaphor and an artifact of language. But there's the question of really whether these things exist independently of our own viewpoint upon these things. I think there's reasonable evidence that they do, but I don't make any strong, epistemological, statement about, these are the right things. When I mention forms, you can think very much of, say, Plato's forms, for instance. But I think, forms in the term Plato, he considers this ideal circle that exists, and it exists in a different plane of reality. I don't go any place with that. I just basically find these things as abstractions that might be applicable and have people dynamics across domains, and they're worth going discussing. So it's been a kind of fun thing to do, and I just wanted to go and share this all with you because I find that essentially I think these terms. I tend to think in a very visuospatial way. And then quite often, if I basically sort of get an intuition around things, I can identify the form that kind of led me to that, and it kind of aids my cognition to some degree. This might have that benefit for you if you want to dig into it. Another little piece of caveat, I'm sure some of you have heard of this. There's, I can never remember how to pronounce his name, but he was an early pioneer in general semantics, and he basically had the little statement that the map is not the territory. And I think this is kind of like baked into quite often the conversations and the worldview that many of us would have in the complexity community, understanding that essentially there's phenomena out there, and then we have our descriptions of the phenomena, and that basically the descriptions are not the phenomena itself. And so this form stuff is really an experiment of going and basically finding maps that are useful across several different domains, but that does not actually go ahead and none of them make a claim to be, the one and only map for things. So I just want to go and offer that as a caveat for what I'm going to be discussing. The other thing I'll mention as well is that this was informed a little bit by one of my favorite authors, Kurt Vonnegut. I remember as a teenager reading this book, Cat's Cradle, and it was kind of fascinating to me because in there he basically described a religion called Bokononism. And in that religion, it had various different concepts, and he had clever names for these things. And it basically allowed him, like all science fiction authors, the artifice of or the device of going and being able to go and talk about something by inventing a language and sort of like hypothesizing what it would look like to go and see the world through the veil of this particular linguistics, this particular, nomenclature in order to go and understand things. So I kind of, several years ago, just made up names for many of these different things, just because I didn't want to go and take a name from one particular domain and apply it across another domain. And because it would just seem kind of odd to do. And also because if you make up words, they come with less baggage. So that's part of what's been happening with this. So first one here is Neaq. Okay, this is kind of an interesting one, because what this is about is just generally about the tension of connection in systems. And you'll see here that essentially this is just showing like a picture of a bunch of people. They have like a network of communication that happens in most every system that you can kind of encounter. But this principle, or this form, which is about connection and adjacency of things, is something which is more general than just social systems. And that's going to be an aspect that you'll see in a lot of these forms, is that they are not just about social systems. They are about physical systems as well. Okay. And it's a generality that kind of encompasses some of these things. So here's another example of Neaq. The left-hand side is a low Neaq environment, and the one on the right is a high Neaq environment. And so Neaq is kind of like this encompassing principle, or this encompassing structure, where it's kind of like you have things that are, if in a high Neaq environment, are connected or very close adjacent to each other. Okay, so that's low on the left-hand side with the desert. And then in the rainforest that you have, like on the right-hand side, things are intermingled in a way. And then it's kind of like in any natural or conceptual phenomena that you might go and encounter, if you have things that are touching, then one thing can affect another causally, right? If there is like even like a laser beam goes from one place to another, that's a form of connection as well, in the sense that communication can occur at that distance for those things. So this is the general principle of connection and adjacency in the system. And you might go and say, okay, well, that's extremely general. What good is this? I find it kind of useful to go and think about in terms of a lot of different phenomena. One of the things that kind of comes up quite often is this notion in social groupings of cliques, right? So you have a group of people, and then essentially you notice that if you have 10 or 15 people, then quite often you might have some subgroup of maybe 3 or 4 people that get there and go and communicate with each other. And that actually we notice as well that as we add people to a group, we quite often get into this situation where there's so many people that essentially communication kind of grinds down to a standstill, or we have to go and basically use things like, Slack and chat apps in order to go and actually sort of have a richer conversation among a bigger group of people. So Neaq is basically this tension of connection, and it tends to increase as the number of participants in the conversation grows. There's an old joke that if we all decide to go to dinner, I think there's about 50 of us on the call here, it would take us forever to go and actually decide where dinner should be. If it was only 5 people, we'd probably decide very quickly where we want to have dinner and do that sort of thing. So this is something which is well known in computer science. There's consensus costs when you have a distributed system. If you have many different nodes, and then basically as the nodes grow, then the amount of time it takes to go and reach consensus tends to become much higher also. So yeah, there's this general thing with this of cliques being this, subgrouping that tends to form inside of larger groupings. So we'll talk a little bit more about that later. The same kind of thing happens in software design, where as you basically have things that grow bigger, you start to go and notice relationships between the individual pieces. Okay, and it's kind of like this sense that for every particular data item we have in this one box here, member, it's not the case that every one is connected to every other one. It's just that some are more connected to each other conceptually than other ones happen to be. So we end up with these subgroupings as we start to grow things in a bigger space. And this just is another aspect of the thing I'm trying to articulate, Neaq. I want to take a slight diversion to go and talk about something a little bit different here. There's something called Galileo's scaling law, which is an interesting thing. Galileo, basically several centuries ago, basically made this observation about things as they scale. And one of the things that he kind of pointed out is that essentially you can't have well, he used a different example, but you can't have an elephant, you can't have a mouse the size of an elephant. And the reason why you can't is that essentially a mouse the size of an elephant would just kind of fall apart because the ratio of the surface area and its strength to the volume held by the mouse's body. As the volume grows, if the surface structure is not able to go and actually become correspondingly stronger, the entire mouse would just kind of collapse in a puddle of blood, unfortunately, right? So it's like there are certain structures that as they scale, they simply cannot basically be, they can't exist in that particular way. And the same thing is true about buildings and cottages. If you take the materials used to go and create a cottage and you basically go and use them to try to build a skyscraper, it's going to fall apart because of the structure, the strength of the structures. But it's not just the strength, it's also the fact that basically the volume increases as the cube, as you increase of things, but the surface area increases as the square. That's why it's called the square cube law, right? So if you have a cube and you have basically the faces of the cube, that's the surface area. And as it gets bigger and bigger, the volume is going to grow proportionally much, much higher than the surface area of the thing does. And it's that tension that goes and leads to large scale structures kind of breaking down in a way. Now, you might be wondering about what this has to do with Neaq. And essentially, the thing I'm pointing out with this is that this is just generally the tension of things as they kind of grow, right? As you basically have more and more connection or more adjacency, more and more pressure. And there's a corresponding law to Galileo's scaling law, which as far as I know isn't really articulated quite the same way. But essentially, when you have network systems, like a set of relationships among people or many different pieces in a network, for instance, it seems to be the case that as the tension grows, it's kind of like you have to go and change your structure as things go and scale up. Otherwise, they're going to go and fall apart in a strange way. So it's kind of like there's this sense in which, in a network, as you go and add nodes, for every node to connect to every other node, you're going to increase as the square of n. So every time you add a node, you're going to basically go up to the next level of n squared. If we have like if we have like 3 nodes, we have 8 ways to interconnect them. If we have 4, we have 16 ways. If we have 5, we have 32 ways. So this is Neaq tension basically going and increasing. Now, the thing is, if that tension has a cost to it, then we basically start to go and run very quickly up to limits that basically go and sort of like say, okay, this structure is no longer tenable for us. And what's interesting about this is that this tends to, in network systems, cause you to break off into cliques, right? And it causes you to break into like federated structure, for instance, in systems. We were talking about hierarchy a little bit earlier. And hierarchical systems can quite often be seen as a reaction to this. If it costs too much to have 500 people talking to each other all direct peer-to-peer, then invariably you end up in the situation where you start to go and actually think about federating the structure in a way. And this is a bit of like what's behind, say, Dunbar's number, for instance. The notion you can have only about 100 people communicating with each other, 100 or 150, before they don't know people by face or name. And then you have to go and start to go and introduce structure that goes and breaks things into subunits. A friend of mine years ago basically told me this interesting story. He was talking about working on a software development team and how they kind of hated talking to the business to go and find out what they needed to do because the meetings were very long and they just didn't like having meetings. But they hired somebody into their team that used to be a manager. And this person said, okay, it's fine. I'm just going to go and jump over to this other to the other side of the organization, the business people, and go and get the work from them, and I'll bring it back to you. And they thought that'd be a nice, ideal solution. But the interesting thing that happened with this was that you get into a situation where that person is going back and forth, and then the business people are going and saying, well, gee, it's like, why were you even talking to you? Because you just run back to the developers to find out whether it can be done or not. And then you start having the manager kind of making decisions on behalf of the developers and ending up having a bit more power in the relationship because they're trying to go and minimize communications, but they have an intermediary, and then there's more power that's attributed to the mediary. And so this kind of thing goes and leads to federated structures in systems. And you'll see this all over the place in hierarchy and things along those lines. So I think it's kind of fascinating because quite often in social systems, we look at hierarchy as being dysfunctional, and it can be oppressive and various different things. And we try to flatten organizations as much as we possibly can. And that's nice. But I think the interesting thing to recognize is that hierarchy is quite often something which is emergent, and it's basically as a result of scaling pressure, this increase in Neaq that happens within a system. And there are alternatives to going and basically making it more humane. You can have temporary hierarchies and hierarchies that are rising and falling within an organization, various different things. But I think the interesting thing is to recognize that this is an aspect of how systems tend to break themselves into pieces in order to go and deal with the pressures of increased costs of like massive amounts of communication or massive amounts of connection and adjacency in the system. So yeah, that's kind of what Neaq is in a way. And I think, it's interesting as well to go and recognize that this kind of hierarchical structure that can be built up from these things, it's not just human systems that get this. When you look at hierarchical structuring of veins in a leaf, for instance, this kind of thing happens because it is too costly to allow point-to-point communication between all cells in the system. So naturally, there's a network that goes and forms that kind of allows you to go and sort of have bigger arteries going and sort of serving smaller areas. And then you're able to go and kind of like, deal with things in those particular ways. So I think it's very useful for us to go and actually see these things as elements of system dynamics that occur across all different kinds of systems. One thing that's interesting that you might want to look into is something called constructal law. And I forget the guy's name who came up with this, but he had an engineering background, and he basically makes the argument that for systems to persist over time, they tend to go and sort of form this kind of hierarchical network structure internally. And there's things you can do to mitigate it. There's things you can do to basically make it less problematic in systems, but we shouldn't be surprised by it when it occurs in systems. So that's one thing. That was Neaq. And, I apologize for how general it is, but to me, in my mind, it seems like a rather distinct concept, and it helps me think about systems in general. There's another one called Exot, which I think is kind of fascinating. This one is, again, also generalized into a rather large degree. But a system is in Exot when basically it encounters a constraint and it kind of grows around it, or it basically goes and sort of like moves in another direction as a result of being constrained in some way. And it's not just constrained, it's also when the system basically sees advantage or opportunity in a different direction, then it will possibly go ahead and move in that particular direction. The example here that's shown in the picture is having a tree and having like a steel band around the tree. And you'll notice that steel band happens to be a very tight constraint on the growth of the tree, but the tree doesn't care. The tree goes and grows around the band, right? It basically goes and opts for growth in a different direction or motion in a different direction, just because of the fact that it's blocked in one other area. And you can imagine this in just about any system, okay? Any system that you have, people tend to sort of like, if you're blocked in one direction, it's like, I'm not going to try to walk through the wall next to me. It's ridiculous. There's a doorway. So I'm going to go towards the door and out the door to go and get outside rather than going through the wall, okay? And it's either I desire something outside the door, or I recognize, oh, I can't go through that wall. It's kind of ridiculous. So there's a gestural aspect to this particular thing. And you'll see this kind of generality in other things too. Imagine you have like a musical band, for instance, and let's say that you happen to be the guitarist in the band, and then there's someone who wants to join the band. Turns out this person is probably better at guitar than you are. It's kind of like, well, you can go and sort of like opt to not play guitar and have the new person play guitar and you play keyboards instead, for instance. So you're basically making a role adjustment, but it's really you opting to go and take yourself in a new direction as the result of either an opportunity or a constraint. So that's the level of generality that we're talking about here. Other things, let's say that you have a job and the job is okay, and then you basically get frustrated for a period of time and you look for other jobs, and then you are an exot because you choose to go to the other place or form a new company or something. Now, it's interesting. I don't know if anybody's ever had this experience, but sometimes you get frustrated with a job and you decide to move on. Sometimes you're frustrated and you don't think about the frustration, but instead you just basically see a wonderful opportunity and you kind of go for it. So did you leave because you were frustrated or because you saw this new opportunity and you're very excited by it? Exot is something which is a little bit more general than that. It's really the motion itself. And it could be the result of an incentive, or it could be to avoid a problem. And I think that quite often in human affairs and stuff like this, it's like there are aspects of both of those that happen in the system. So Exot is basically choosing to move in a different direction. And it could be basically sort of thinking outside the box in a situation. It can be anything along those lines. It can happen in conceptual systems as well. One thing that's kind of fascinating is when you look at mathematics, there was always like this interesting thing where if you take the square root of numbers, you can find, the square root relatively easy in mathematics until you encounter negative numbers. And for a long time, basically, nobody really thought that would be a worthwhile thing to do. They didn't even know how to define negative numbers, but then they created a placeholder called I, the imaginary number, and then basically sort of birthed the field of complex numbers, basically going and saying, we are going to sort of like find an exit from the system and basically go and have a wider frame that we're able to go and participate in by simply going and sort of breaking through a particular constraint and leaving the existing system and going and encompassing a bigger system. So hopefully you can see that there is these are very, very general concepts. And I just find them rather useful to go and frame particular things. And yeah, fair enough. Parzo, okay, is another one. And this is one which is really about dynamics and systems when proximity when connection doesn't have very much cost, or when you seek different connections. This is essentially like a map of airports in the US, right? And you can see that there's Chicago and Kansas. No, these are train routes. And no, okay, I guess the airport. Excuse me. But essentially, you can see there are certain hubs, right? They basically have many, many connections, and others that have fewer connections. And you might wonder why it is that maybe Chicago has like many, many more connections than some of the other airports here. And the interesting thing about this is that essentially, once you have a particular airport that has many connections, then the relative value of it is much higher. And then you end up in this situation where people want to connect through it because of the other opportunities that it affords in terms of many other connections. So there's this thing that's sometimes called the Matthew effect, like the rich get richer. And this kind of thing happens in systems where there's preferential attachment. And often you'll sort of see this in expressions of power law dynamics and things along those lines. So this general thing is not just power law dynamics that you would have like airport hubs and income inequality and all these other things. But it's just this general thing of going and having growth, which tends to engender more growth and tend to go kind of exponential in some sense. So yeah, typically you'll see something like this in graphs. This is like a long tail distribution where you have things towards the origin. You have many, many things that have a very high number of connections, for instance. Then you have a trailing number of things that have low connection, for instance. And this kind of dynamic occurs in many, many different natural phenomena. It's interesting that this happens, quite often in money. It happens in virality, like picture of a virus there. It also happens as a general degree to attraction, like things that we find are cute. We basically sort of like, the picture of the cutest kitten in the world tends to win in terms of like how many people will retweet it, for instance. And you'll basically see the same kind of curve when you're looking at this kind of phenomena. This is a very early picture going and showing follower counts for Twitter. Essentially you'll see that basically there are small number of accounts that have many, many more followers than others, and then lots and lots of accounts that have proportionally fewer followers. Now, it's an interesting thing about this that, sometimes people look at this as being problematic, and it can be in many different phenomena. But the interesting thing as well is that because some of these things become kind of popularity contests in a sense, you have like this kind of signaling that occurs when you say, okay, well, here's a Twitter account that has many followers. Chances are this will be more interesting than one that has fewer followers. Now you can basically go and do the counterintuitive thing of basically choosing follow only accounts that have small number of followers. But in terms of going and actually sort of seeking things and basically seeing value in things, that could be decent. The reason you end up having more followers is because you end up in this situation where the success of the account might signal value, and then people go and use that as a proxy for value, and that helps them kind of find things that they might be interested in. And it's interesting with this too, that this is not just power law dynamics. I can basically, point to hierarchical structure as evolves in systems as being an aspect of Parzo also. The sense in which we basically go and introduce where complication arises within a system and produces nonlinear effects of increasing value. And so Parzo is like a general term for this particular phenomena. And Parzo is general enough to go and actually encompass things like gravity, for instance. If you have a small rock, it has very little gravity associated with it. If you have a big star, it has a lot of gravity associated with it. So much so that it will suck in other stars and become bigger. And as it gets bigger, it has more gravity. And then you basically have more things that kind of fall into it. And of course, the far off point with this is like a black hole, for instance. There's a sense in which you are increasing as you get more stuff, and then you increase to the point where basically sucks in all matter and stuff along those lines. So this is a general aspect of systems that tend to kind of go nonlinear in a way. This dynamic. Odon is another form, and it's somewhat related to the Neaq thing that I mentioned before, the tension of connection in systems. And it has to do with the way that systems tend to kind of like break down into smaller pieces. I used the word clique before to go and describe that in social systems, but you'll find this very often in other systems as well, that if there is a way for particular pieces to seek value or grow in one particular area, if there's a limit to that particular growth, then basically you'll have growth happening in many different areas. And these different areas tend to go and sort of crop up, and then you tend to go and have, these, it's rather than having like a big uniform space, you tend to have fracturing of things and, like local hubs and things along those lines. And so this is, again, very general and encompasses a lot of phenomena. Look at meiosis, for instance, as an example of Odon, where things basically break into two, for instance. Other aspects of this, one of the things I find kind of fascinating is that clique behavior that you can basically find within organizations. As an organization grows, then you'll basically have subgroups of people that basically get together to go and do various different things. Natural aspect of some of the pressures that occur within social systems. And of course, this is a generality. It isn't always true. People can span relationships across an organization in order to go and do various different things. But we shouldn't really be surprised when we basically see situations where you quite often have this kind of break apart of things into smaller elements. A way that this occurs quite often in systems, in software systems, is through modularity. And this is a result of another kind of scaling pressure. When we are designing functions in programming, if they become too large, then essentially we get to the point where we can't understand them very easily. If we keep them small, then essentially we're going to fit implementation or head and kind of understand things. Much the same thing for bigger structures, structures within programs like classes and services and things like this. There's a limit past which things are not easily understandable. And for that reason, we tend to break them down into smaller pieces. And this is another aspect of Odon. We break things into pieces in response to particular pressures that occur within systems. Okay, another one is Cirlo. And Cirlo is an interesting one in the sense that it is a systems phenomena where you have a great deal of pressure in a system and then somehow the pressure is released. And when this happens, it's kind of like there is like abundance in that space. And you can look at the analog for this as like a sprinkler, and then basically you have like a little nozzle. Due to the pressure, you can have like a very fine spray that's going to go and come out from this particular thing. If you have a dam and basically the dam goes and breaks, you're going to have like a giant gush of water when you're doing things like this. In human systems, you might say this is just a metaphor, but let's say that you basically are expecting to have like a meeting that you're dreading one morning when you wake up and suddenly discover that that meeting is canceled. And not only is that meeting canceled, but all your other meetings are canceled. And then you feel buoyant because you basically have a space of possibility open to you, because there was the abrupt release of tension, the abrupt, creating of a space within a system that allows you to do things that you wouldn't normally otherwise do. And that's roughly what Cirlo happens to be. So a way in which this can kind of happen is, oops, I think I have the wrong one here. Yeah, Cirlo is basically sometimes this creation of abundance from a previously stressful situation. And one thing that's interesting to note is that people will have different theories about why this happened, but in the US, we had the baby boom that happened like after World War II. And there was this sense that essentially, there was the end of the war and people were relieved by this and felt that they had bright horizons in the future. And as a result, had many children. And then you have a giant population demographic wave that occurred. So it's kind of like moving into a space of abundance from a previously pressureful area. And, I would argue, that this is not just a metaphor. This is something that kind of happens when you hold systems in pressure or suddenly release pressure that wasn't previously realized. You can end up in this space where it's kind of like everything is good and people are happy and things are happening in a good way. I like to use social media as an example of this. And I don't know how many sociologists have looked into this particular thing, but I remember the early days of Twitter, for instance. And in Twitter, one of the things that was fascinating is that there was a good period of years when, as it was growing, people were just very happy with it and doing wonderful things. And then at a certain point, it became kind of gamified in a way. And then you have harassment and all sorts of things that basically bothered people. And it seemed like there was this space in the very beginning where there was like people were exploring the possibilities before it became something that was very hard to go and deal with and ended up having various different kinds of pressures. So I'd say that, Twitter was in an early Cirlo state, and then basically the Cirlo dissipated at some point in time. And that's just the name I would use for this phenomena. Endot, okay, is a general protective function that happens within systems. Imagine you're in a house, you're there with people family and stuff like this, and you feel safe in this particular house. And it's not like you're going to open the door to a bobcat or a mountain lion and let it in. So you feel absolutely safe in that space. And in much the same way, if you have, for instance, a coconut, for instance, that has a hard shell, and that's kind of protective in some sense. Now, you might look at this and say, how is this a general systems principle? But imagine having a group of people, and essentially that group of people are very welcoming. We can get back to Popper's paradox at some point with this. But at some point, you have somebody who comes in who's a bad actor, and then essentially things start to break down, and there's infighting within the team and stuff like this. You can basically deal with this in a couple of different ways. One of them is to go and have a very high barrier to entry, only let in people that are vouched for by other people, for instance, or have very strict rules and basically sort of kick out people that don't really adhere to those particular rules. But it does seem that for systems, and quite often for many systems, to actually preserve themselves, there is some kind of protective function that tends to kind of like emerge in them. And that's just I use this general word endot for that particular thing. And again, it's interesting to notice that this is something you can discern in physical systems as well as in social systems. And we could say it's metaphor, but I think it's no mistake or no accident that these kind of things happen in these different spaces. So I think one of the things that's kind of interesting about the time we live in, like living online, for instance, for many of us, is that there was this degree of locality that we quite often had in our lives before this just kind of dissipated. You can basically be affected emotionally by something that somebody says thousands and thousands of miles away from you if you happen to basically encounter it. And so in a way, we've kind of like sort of evaporated the locality that used to exist in the world. And so there are fewer protected spaces in a way, or if we want to protect space, we have to basically decide to be offline or something along those lines. So there's this term we can kind of use for going and describing that particular thing. There's this other thing too. A lot of these things interact in various interesting ways. There's this thing where if you see something that has protection, quite often that kind of signals to us as biological organisms that there is something good about it. For instance, if we see a protective mechanism around nuts, we might think, oh man, this nut is trying to protect itself. to the degree that it actually tries to protect itself, there must be something good inside, right? So there is this signaling aspect that can kind of happen in systems where if you see a strong protective layer to something, it could mean that there is something of value there. And in much the same way, you can see there's an interesting question of like, okay, there is cuteness of the kitten, right? And everybody loves the attractive kitten and stuff like this. But is there any Endot to that? Is there any protective aspect? And I think in a very loose manner, you could go and say there must be, because if it is, if it is that cute and vulnerable, then for it to exist by itself without, being hurt by other animals in its environment, there must be some protective function. And generally that would be the family or, whatever tribe or whatever is able to go and sort of care for it and nurture it as it grows into a cat, right? So there is this interesting aspect where sometimes the Endot is not apparent, but you can actually see it through, just inference of the dynamics of like, is this a valuable, vulnerable thing? Is it? Then where's its Endot? If it exists and it has not been, taken in some sense. Honho, I think it's one of the last ones to go over before we kind of open this all up for discussion. This was like an experiment in going and sort of like coming up with a terminology to go and represent things that have aspects of life but aren't quite alive, but could be alive, for instance. Honho is basically when you have a system that requires the constant regeneration of itself in order to persist in time. So two examples, here. One is like an iPhone, for instance. There are no real moving parts to an iPhone, for instance. And so I think if it breaks, just about the only thing you can do is sort of like change the lens, for instance, and that's about it. If anything breaks internally, you're just really in trouble. So this is a very low Honho mechanical device. If you look at an old car from the 1970s, for instance, many things can go wrong, but basically you have a maintenance schedule. You can have people come in and change the oil. You do things, you change the belts and stuff like this. And so the system around the car is alive in the sense that it has to go and have constant care in order to basically persist its structure over time. So it's an interesting thing in technology that we are moving more towards low Honho devices in the sense that they require less activity and regeneration in order to persist over time. And the things that tend to require more of this regenerative capacity tend to be things that would be more in the space of being alive, right? So if you have a club of people, they basically might have the rituals, and they have the things they do for their excitement as a club, and that's the liveliness in the Honho that basically goes and maintains the durability of that club of people over time. And just like human bodies, for instance, it's kind of like there's like a regenerative capacity that goes and happens to go and basically keep ourselves alive over time. Same thing is true of any kind of social system as well. You can look at tornadoes, for instance, or hurricanes, and recognize that they have this aspect that there's kind of like there's a sense in which they're gravitating towards air of a particular temperature in order to persist themselves to the degree that they're able to go and do this. They're in a feedback loop where basically the system persists over time. If that feedback loop is broken, then essentially the system goes and dissipates. So some of these things are things we would categorize as alive, and others are things that we wouldn't. But this is kind of like a rather cybernetic point of view of systems to be able to go and just have like, a placeholder word for these types of systems and be able to speak colloquially about things like this. Let's say, for instance, if you're in software development, you might sort of see an open source project, and you say, yeah, this one is not really in Honho right now. It's like, oh, what does that mean? It's like, it's just, nobody's really contributing to it anymore. Nobody's made any changes from the past 2 years. So in a way, it's kind of dead, right? But, we could speak metaphorically and say, well, the system is dead, right? But having a term which describes this regenerative aspect of systems that keeps them persistent over time is a rather useful thing, at least in my opinion. And the reason why I kind of coined this one is just because I think that we have this interesting space within systems thinking and just more broadly within society where we're often looking to go and say, what is the thing that basically makes humans different from everything else, right? And we're very interested in this because we are humans. We want to persist ourselves. So there used to be that we would say humans are different from animals because we have language or we have tool use. And of course, then we find the counterexamples and discover that we're not quite as special that way as we might think. I think in much the same way, it's kind of like if we are able to go and appreciate systemic patterns that occur across things that are alive and not alive, we are really seeing things at a deeper systems level, and perhaps appreciating ourselves within the fabric of everything, rather than going and sort of like maybe being a bit preoccupied by what we basically sort of tell ourselves about our uniqueness in a way, right? It's an interesting thing to go and consider that sort of thing. And I think it's one of the things that we kind of flinch away from sometimes, this thing of going and finding broader frames for understanding phenomena that could be useful for going and seeing these commonalities. So anyway, that's pretty much what I have here. And I apologize for how quickly I went through this. I don't know how much of all of this landed. I'm looking forward to talking to you all to go and get your reactions to this. But I do want to go and basically say that essentially this is been like a private experiment in a way of going and articulating for myself things that I sort of see in systems, and it's trying to go and figure out what are these core things, and yeah, maybe develop a little bit of language around those things in order to go and sort of like find commonalities across different kinds of systems and examine ways in which those commonalities might be beneficial. One last thing I'll mention is the very first one we talked about, Neaq, right? Tension of connection and stuff like this. There was one time I was working with a team in software development, and it was kind of funny because I realized that that there was a thing I saw in a technical system that would really apply in that social system, in the sense that they basically were waiting on another team to go and do some work for them, and they could easily just do the work themselves. And that was like basically making the tension of connecting that team to another team evaporate by just incorporating the dependency rather than going and keeping the dependency. And I've seen that same kind of thing happen in technical systems all the time, where this dependency is problematic. Why don't we just go ahead and have this part of the system do that thing together? And to me, that common gesture, it's like if you can see it in one system and see it abstractly, then you can apply it to other systems and perhaps find novel solutions to systems that may not have occurred to you previously. So at this point, I want to just kind of like open it up to people and just sort of mention that anybody who's interested can contact me on Twitter, mfeathers, and I'm always eager to go and talk about this and gain more reactions to it. I only went through a few of these, but these are the names of the 14 forms I kind of identified in my own little language of phenomena. So yeah, let me just go and open it up then. Thank you.
Thank you, Michael. That was awesome. It is, I mean, I just want to say to you that if you're looking for people who like to talk about complexity and abstract thinking, you're in the right place.
Yeah, I hope.
It's kind of what we're all about. So I found it very interesting, this use of, essentially made up names, because we talk a lot about how language informs people's perceptions of a lot of these things. And so this is a very interesting approach to me, but I will now, if I'll ask you to stop sharing your screen for a moment so that I can
Sure.
see everybody's hands and questions.
I had a quick comment while you're doing that is, speaking of forms, the forms that cut across all your forms, as I was thinking about, is energy gradients kept popping up in my head. Whatever is the flow that requires the least amount of energy, or the lowest energy cost, seems to be a recurring theme going on there. And in particular, one that came to mind is the scaling problem, or we're constantly talking about in organizational redesign or agile, let's say, is breaking things down into smaller pieces. And I forget which one it was, obviously, but the cost of what I always call the cost of communication actually is reduced. And that's one of the major reasons why you want to break things down into smaller pieces, because you don't have to maintain that high energy state of keeping all of those connections in place. And then those things can flow through, which is another energy gradient, essentially, of things flowing through the system, which further reduces it's looking for its own efficiency with the balance of the payoff versus the cost. And that's what I was seeing kind of shared across all of these different ones.
Definitely. And it is like, there is like a mechanical kind of quasi energy, view of these things. And it's rough for me a bit, because I know sometimes if you talk to people who are engineers, Let's say it's not really energy, we're using energy in a woo sense or something like that, right? But it's kind of like, I think that essentially to the degree that basically the mathematics describes things which are gradient-like, then it's perfectly acceptable for us to go and actually take seriously the intuition around these things, as it persists across these different phenomena. So I totally agree with that. And, like Neaq, for instance, the tension of connection. I mean, to me, I didn't go this far, but to me, it's almost like matter has very, very high Neaq. Energy might maybe have a little bit less, but it's like the degree of complication and complexity is this thing which can basically, if it incurs costs, go and force, the separation into smaller pieces that you mentioned a little bit earlier. So it's these general things, but yeah.
Oftentimes tie in information as energy, or in terms of information flows, it behaves very much like, or you could actually make them synonymous with energy flows. But anyways, thanks. That was awesome.
Okay, so we have some. Okay, is there more? I just want to move on to the next question.
How do we do this? Are you going to moderate, Barbara?
I'll try to because I see there are some in the chat, and I think Kevin was first up. Kevin, do you want to unmute yourself and ask your question?
Sure. Can you guys hear me?
Yes. Yeah.
Great. So I've seen this and done a lot of research around, when you're developing enterprise systems. So I used to work at FedEx, right? And we have all the world's largest customers as our customers building systems. And we'd inevitably run into the issue of you design a system to meet the needs of the 80%, and then they'd fall apart once you got to really the 0.1%. And so I was looking at, like, Walmart is 263 times larger than the smallest Fortune 1000. I think it's 13 million times larger than the average sole proprietorship. And but you have that same relationship you're talking. I've referred to it as hyper Paretoism. It's the 0.1% that drive so many things. And I was curious, I'm not a mathematician, really not very good at math, but what's the math that you use to describe that? Because it seemed to align to a lot of the stuff that you were showing in terms of that very, the long tail, and then that really steep, 1.1.01% that drives so much of complexity and impact.
Well, generally it's Pareto distributions. There's I hope I'm pronouncing his name correctly, Alberto Barabasi, who wrote a great book called Network Science, and basically goes into, he's done basically specialized in power law distribution, dynamics. Beyond that, Nassim Taleb, in a very folksy way, has written a lot about anti-fragility, which basically has its tie to nonlinear, not nonlinear, but to distributions with fat tails. And so that, he gets into a lot of how this basically plays out in the risk space, and you can look at structures possibly breaking down as being risk being an aspect of that particular thing as well. So I think those are the touch points I would really go and point towards for math. One of the concepts that Taleb talks about is ergodicity, which is generally a statistical relationship. I know I'm going to butcher this, where the chances of things happening in ways that are bad. I would encourage you to read about ergodicity. I think that's I'm losing it right now. I've just haven't looked at that in a while.
Yeah, because one of the things that I've seen is in developing enterprise systems is that people overlook the impact and complexity. They think they're almost done, and they get to that last few customers, those last few use cases, and those ones drive 90% of your complexity and impact. And so I was just curious, have you seen anybody develop kind of formal approaches to that? I mean, I developed my own uncertainty, complexity, really impact framework, but I was curious because that is a
not really. I think the thing that I keep coming back to with this, and really it doesn't have a mathematical basis, but for all my years working in software development, it feels like having a strong point of view about what the system is for and what it is not for. Quite often we get into situations where basically we have like 80% of what we want to go and increase that, and we get into those particular things where by going and adding particular features, we increase the complexity to the point where the entire system goes and breaks down. And that is really a horrible situation to go and get into. And a lot of it comes down to possibly having like a product owner who basically is willing to go and say, no, that's not what this system is. Or that feature right there, that is not this system. It must be another system, that kind of thing. So it seems like there's this sense of going and having a system with enough, with guarded integrity that keeps you from going and basically seeking reward in directions that will go and break the integrity of the system itself. And I don't see a way of going and making that mathematical offhand, but I think that that's the area of practice where things need to be dealt with. So as somebody who spent years and years working with legacy code, I see this all the time where basically systems are kind of like, mutated to do things that were never intended to do. And then you end up in a world of hurt because of that. And it really comes down to this sense that they've gone beyond what the original intention was, and the amount of complexity that incurred causes massive unpredictable effect. And it sounds like that's the thing you're talking about. One of the other forms I have there is called airtoe. I was going to discuss that today, but it's really about a thing growing into its structure rather than adding wildly different structure. It's kind of like you have an orange, and it basically starts out with a certain number of sections in the orange. It's not like it's going to go and get many more sections. These will grow out over time. And basically that's the plan for its growth. And you don't do the thing of going and budding off oranges on top of oranges, because that would be problematic in a way. So.
Seems to me that's problematic of many governing constraints, right? It's not just legacy code that applies to. It's the constraint that was applied is no longer applicable, or the system's changed since then. And that is a huge problem because they stick around and they're very hard to change.
Cool. Yeah, definitely.
So we have one question from the chat, and then Shripad has a question. And so Edmund Morris has asked, can we talk a bit more about the interaction between principles or forms? For example, Cirlo creating space for or as a result of Exot.
Exot, yeah. It's something I haven't really investigated deeply, but I do basically notice that there are like transitions that kind of occur in a way, right? I think Exot is kind of like a thing which happens in the context of Cirlo. As you decrease pressure, then essentially you have motion in another direction. And that's essentially what Exot is. The space after Cirlo, when basically there is not as much Neaq as there would be before, not as much tension, that's a relationship between those things that tends to be causal to some degree. But I haven't really sort of articulated those. I just basically find that when I'm writing about the forms and want to make reference to other forms, then I'm basically happening across the things that you were mentioning, which are really things that are, relationships between them. For instance, the interesting relationship between Parzo and Endot that I mentioned earlier. Parzo basically being the more power law dynamic, and then basically how protection goes and manifests itself in conjunction with that in many systems. There's a story to tell about that, but I guess that's what I would say. Does it make sense, or?
And I hope that was good for you. It made sense to me. So next up we have Shripad. Do you want to, I hope I'm pronouncing your name correctly.
Yeah, that's correct. Yeah.
Hey. Yeah, we communicate back and forth online periodically.
Oh, okay.
Yeah. So one question that I had is, so you had shown Exot as coming or breaking some sort of constraint in different ways. But what happens if there is not enough energy or energy to break out of that constraint? For example, in Japan, they actually produce square watermelons by constraining the shape of the watermelon itself, right? So that's kind of reverse Exot, but
so I think the main thing is that it's very likely that Neaq will increase the tension of connection, adjacency, or pressure. So and the deformation of the watermelon's protective layer, its Endot, is mutated by the fact that that pressure is increased. So I think that's just the general thing. And it's like, if you think about a situation socially that you would rather not be in, you can feel your tension rising internally if you can't actually leave. right? So there's that parallel between these things. So I think at this very high level of generality, the general thing is that if Exot is not possible, then Neaq increases. And this could basically lead to other things. It could lead to federation internally. It could lead to Odon, which is the thing of it breaking off, of the system breaking off into smaller, more active pieces, for instance. Yeah, it really depends upon the system, but that's my first, I guess the first thing I would kind of like offer in that space.
I mean, it's interesting to talk about it, right? Because at some point it will break open the jar itself, which is constraining it, right, as well.
Oh, break open what?
The jar which is constraining the watermelon itself.
Yeah. So you could do this, and that can happen externally. I tend to think of Exot as being something which is, it's always like, thinking about the system as a whole, or basically thinking about the contents of that system going and breaking through in some sense. Yeah, I think in my framing, usually it isn't some external agent breaking the jar. It's more like the tension of the watermelon breaking through.
Yeah.
That kind of a gesture.
Or the system itself degrades, right? It just ceases to grow or to expand or whatever. It could eventually break down, or it could stabilize within that space. Yeah.
Right. And it's funny because I mentioned Honho in the talk, which is like this general thing of like things persisting itself through activity over time. The opposite of that's something I call dirge, which is when things start to go and, decay in metabolism so that they don't really become active. So if you have a terrarium and then basically it is not like a sustainable ecosystem, it will die internally, right? The watermelon, I don't know, it's funny with this. The watermelon becomes like infected and turns into like this, giant, pool of bacteria. That's, Honho, that's basically induced by this, not necessarily the pressure, but an absence of Exot in a way, or absence of connection to an outer world.
It's good for the bacteria though, right?
Fair enough, yeah.
So one comment, I think you were explaining rat becoming elephant and so on and so forth. I think it's called allometric scaling.
Yeah.
So that's a pretty interesting phenomenon to learn about.
Yeah. I didn't mention that, but that's I've read about that. I was doing a lot of reading into scaling in general at one point, but yeah, definitely.
Okay, so who has the next question? Okay, I see. Andrew asks, Andrew, do you want to unmute yourself and ask a question, or do you want me to ask it? There he goes.
Can you hear me?
Yes, we can.
Okay. Hello. Can you speak on letdown phenomena in the context of this language? Letdown being things like getting sick on the first day of vacation. Is that like a Cirlo of Endot sort of situation, or is there another
Let's see. So yeah, not familiar with letdown phenomena, but it's anticipatory. Would you look at it as being like anticipatory standing down rather than engaging in something new? Can you give another example other than getting sick on first day vacation? Would you help me see?
I mean, I think that's the most salient example, where you're kind of, bolstering yourself, and then there's some kind of transition where your body's like, okay, I can relax, and then the stressors that have been kind of existing, that have been maintained, are now being released in some way, and you kind of go through that rejuvenation process.
Yeah, I would look at that as like a system trying to maintain Honho, which is that regulatory life thing, which is almost like homeostasis in a way, right? So if the system basically looks like it's going to go and exceed bounds in a way which might cause a violation of its functioning, then it might proactively go ahead and sort of like reduce its vitality in order to go and sort of like readjust and basically prepare itself to go and engage later. So it seems like it's kind of funny because if we look at letdown in terms of sickness, it's like there's an aspect where it's like, oh yeah, I feel sick and I'm the agent that feels sick, but there's perhaps also this deeper level at which the system itself is understanding that it's not ready, and it's going and doing the work it takes to go and actually prepare in some sense. I don't know. I don't know letdown phenomena all that well with it, but I think the closest thing I can see with that is really, Honho, which is kind of general homeostatic regulatory. And I guess the other aspect of this is, it might be an aspect of Cirlo as well, right? So Cirlo is like the abrupt release of pressure. So it's probably like that in the sense that we're reducing Neaq by going in and reducing pressure. And it's not like you're going and having a party or something like that, but you're kind of like collapsing into a freer space. So I guess it seems to me closest to Cirlo in a way, in response to a regulatory function, which is more like Honho. Does that kind of make sense?
Yeah.
Okay, so yeah, I guess I can see in your comment you mentioned Endot also, and I guess that the protective function might be the thing which induces that kind of local Cirlo in order to go and sort of enhance the fitness of your biology, I guess, your personhood. So, but yeah, I like that insight, and that's really cool. I haven't heard of letdown phenomena before, but it's great, good.
Okay, great. So let me see if there's any more questions. I have, for me, it's sort of interesting, and I see Bao and Michael and Chris and Bruce are here, and they'll probably tell me I'm wrong, but I was sort of thinking about what you were. Yes, Chris is already shaking his head yes that I am wrong.
Which Chris is?
Chris Matz.
Oh, okay. He's here, good.
So I was sort of thinking about Postel's law in terms of this. We often talk about there being a sort of ordered and unordered, side to complexity. And there are certain systems where you want to be conservative, both in what you let in and what you send out, right? When you have so that there's, we talk about the sort of ordered domains and the unordered domains. Yeah. And I think that, that particular law actually needs to be adjusted depending on what kind of system you're talking about.
Yeah. Can you say more about how you would do things in response to either ordered or unordered?
Right. Well, so like on the unordered side is where we have a lot of what you're talking about when we're talking about complexity, right? Lots of different interactions, lots of different connections, things are shifting, and there you do want to be liberal in what you accept and conservative in what you send out. But on the ordered side, right, that's where we have to have systems that, sort of factory type systems, or systems that have to run in a particular way, very clear, sort of systems. And there you don't necessarily want to be liberal in what you accept. You want to be maybe conservative in both what you accept and what you send.
Yes.
Bruce, tell me I'm not wrong.
Barbara, Barbara, I can't thank you enough for what you just said, and I'll defer also to Michael on this one as well. So yeah, I mean, all the situations that we humans experience, they're not the same, and there's stuff that we know, there's stuff that we can know, and there's an awful lot of stuff that we don't know, and we don't know, and there's stuff that we know we don't know that is unknowable. And how we act and how we communicate, every person, we all bring our own little minds to and our lives to the moment and to try to figure out what's going on and what we're going to do. And in the things that are the most complex situations, how we communicate and the information, I put into the chat about a word that when I first even learned about complexity, I didn't know, which is dynamical. We know dynamic, but there's dynamical. Every living agent in the system is continuously affecting and being affected by everybody else. And I'll leave it there and see if Michael or others have something to contribute on this point.
Sure. Let me just go and thank you very much for that. And it's kind of funny because I did apologize for this not feeling like complexity in the very beginning, but what you mentioned and also what Barbara mentioned, I'm glad you brought that up, because the thing is when I look at Lavin, which is the word I use for Postel, just to go and have a blanket term for it, it seems like if you have Endot or protective function, you basically are creating an ordered space where you're able to go and sort of like have enough protection to basically make sure that like factories will basically go and do this thing of reducing tolerances. So it's not like having a wide tolerance, but basically having everything machined almost precisely to go and basically gain efficiencies and stuff like that. So they aren't like participating in a broader market where they basically have to go and create something that's going to fit with anything, like a Lego. They are able to go and basically fit things precisely in a way that goes and satisfies their local space, but they've created an ordered space for this kind of thing to occur. So there definitely is that aspect of it. Now, with the internet browser wars I mentioned a bit earlier, that's because it was a competitive landscape. And it's like everybody's trying to go and actually sort of like do the better things. They have to basically tolerate like wide range of input and basically be open to all comers, all competitors, and all market participants in order to go and actually do the things that they need to do. And it's kind of fascinating that kind of dynamic happens with this. I think the thing that is interesting with this is that companies do this as well. It's kind of like, we're giving you our service for free, but guess what? 6 months from now, we're going to start to charge for it, right? So it's kind of like, we'll accept anybody as a customer, do anything we want. But then later, it's kind of like, then we will raise the cost of actually be participating. So to me, it looks like Lavin or Postel is kind of like a growth move in a way. And it's not something you would want to do all the time, but as you create a protective space, you want to kind of like raise the barricades a little bit to some degree to go and maintain the order you need to basically persist the system. And this is why we get upset when people say, oh, Postel doesn't work. And it's kind of like, well, maybe you're not seeing it as a strategy. And maybe you're not recognizing that whether you want to use the strategy or not, it is a strategy which has the specific behavior that is articulable and understandable and reproducible in systems. So, yeah. Can't hear you, Barbara. I think it's.
Yes, Jaco just pointed out that hierarchy emerges because, he has to say that at least once a meetup.
Mm-hmm.
Is anyone else? Chris Matz, do you have anything you want to add?
I mean, Michael knows I'm just such a huge fan. I mean, he took out a restraining order on me so that I wouldn't keep following him everywhere. And I'm a huge fan of this work that he's doing as well. I don't know if he shared the images, but the artwork that goes with it is also incredible. So if he's not done that, if we could harass him into just sharing perhaps one of them for the rest of the group. I have to apologize. I've got to go, and I'm so sorry I wasn't here because I was so looking forward to this. But
that's recorded, so that should work now.
Yeah, but yeah, it's awesome. As I say, if you can try and twist his arm to show you some of the art as well, because it's brilliant as well. Anyway, huge fan,
Thanks,
and I promise to stop stalking you at some point. Cheers, Michael. Thank you for sharing. Bye.
See you, Chris. Thanks.
Have to apply that protective barrier, Michael.
Yeah. Yeah. We know what he's like. Michael, I did want to ask you. I know you mentioned Twitter. Do you have a place where you blog or post some of your ongoing work on this regularly, or?
Not really. I really need to go and do this, and I think it's kind of good. I really am enjoying the. I guess the affirmation of this group, basically going and hearing these things and not telling me I'm insane, at least you haven't so far. But I find it difficult to talk about these things because they are at a very high level of generality. So there's always been this issue of like, well, what is the audience with this? But I did register a Substack a while back, and maybe I'll start do some with that, and I'll send you a link. Maybe you can go out to people who are interested, or I'll tweet about it and get people involved if they want to go and hear more about this.
I think it would be interesting for you to find, like, this audience. We are very familiar with the underlying concepts of what you're talking about. Your approach is different for us. And that's, I think, where a lot of the overlap. Almost everybody that has attended this meetup today has some background in understanding, abstractions about complexity and complex theory, and also this distinction that we talked about earlier about ordered and unordered and things like that. So, you may have found a sort of audience for your thoughts now that you had struggled to find before, because for us, this is all very familiar. It's just that your approach is what is unique. Val, I'd be interested in hearing anything that you have to say about this. are you just going to ignore me? There he is.
No. Yeah, I was very stimulated. Thank you, Michael, for your presentation. And I was thinking about, your last concept that you introduced, the was it Honho, right?
Yeah.
That of course, what makes human beings pretty much unique is that we are aware human beings, but we are also aware that we are aware, and that also distinguishes us from animals who are often aware, but we have this other level that we can enter, and that was something that came up for me. And of course, machines like the iPhone or the car that you introduced are not sentient beings. They are not aware, but they can grow as you because of software possibilities and all that.
Yeah.
So that came up for me. The other thing, because it was a lot for me to take in, that intrigued me was maybe you can share what your view is when we were going through the pandemic. How do you then see the pandemic, looking at your lens, through your lens of thinking?
Oh, wow. I think the thing that's been very interesting to me about the entire pandemic is the degree to which the world has been interconnected. And the world's always been interconnected from the earliest days of, people going from place to place and stuff like that. But the degree of interconnection we have with supply chains and everything else is just phenomenal. And the degree to which, viruses can spread from continent to continent and, city and nation to city and nation is just, kind of wild. And I think the thing that kind of gets me from the point of view of Mike's software background is that, when you put all of your eggs in one basket, it's kind of like, you better take care of that basket, right? And that, a valid way of going and approaching systems design is if you have things completely separated from each other, then essentially you have some redundancy, which is a nice thing to do, So yeah, that's the thing that kept coming to mind, is that essentially, perhaps the pandemic was inevitable to some degree, because of the amount of interconnection we have in the world. And I think that's been something we've been warned about for decades, that's a very likely thing that can occur with us. And then, you start thinking about all the different possibilities around this. It doesn't seem like it's very easy to separate one area off from another completely. You'd have things like autarky, I guess, which is just like full self-sufficiency and doesn't quite work. But it's, it's just kind of a wild thing. And I guess that's where we start getting back to the thing of how precarious our situation with our planet happens to be. So there's that. And I think, beyond even the pandemic, I'm often thinking about like online culture and things like that, and just noticing how what we call polarization is also a great degree of fragmentation. It happens in areas of thought and stuff like that. It's a very chaotic environment that we have because of people seeking advantage and then forming out groups left and right, like, this person believes this about complexity that we don't believe, or, just using complexity as an example, just many other things like that. And those dynamics really kind of manifest themselves in an online space to a degree that they would not really manifest themselves in a physical space where you have geographic locality and geographic distance mediating things much more than we have mediators now. So those are just my thoughts on this about it.
Yeah, thank you.
Sure.
Yeah, the other thing I was thinking about, I'm sorry, go ahead, Jocko.
Well, you just triggered a thought on it's not the protective nature necessarily, but how one responds to risk or potential harm. For some reason, what you were just saying there is probably a key aspect of this as well, in order to self-sustain and the response mechanisms that are built in to be able to do that. Is that built into anything in there?
I guess general Honho, I guess. I mean, and just I think as harms multiply, then basically your protective function grows, right? And you tend to basically get in this space where you want even more protection because of the chaos in your environment. And I think that's
I was kind of thinking of more of a response to it, whereas one might attack, let's say, or one might expand, or one might shoot out, rather than reinforcing the protectiveness of it. You respond in order to mitigate that risk.
Yeah, I would look at that as a general competition thing, which is probably more Parzo-ish in a way, more like viral growth. Like we want to grow or expand into a region. You know, if you look, sadly, like Russia going into Ukraine or something, right? I mean, there's an argument that says they're doing this as seeking advantage, but there's also an argument saying that they're doing this because they feel disadvantaged and they want more advantage. I think there's things like this where you can basically attack from a poverty mindset. I guess it's the same thing. If you're attacking from a poverty mindset, that's often seek advantage because you feel impoverished.
What's the idea of a preemptive attack, right? Before you are attacked, that puts you in a position of advantage, but you could spread that metaphor out throughout the entire system as to why what is the agency or the why.
Yeah. I think it's all different levels that these things can be applied at, right? It's wild with this. The thing I keep looking at for like responses is like Exot seems like a good thing. If you can basically, you're in a company, you don't care for it, start a new company, that kind of thing, right? But in geographic spaces, there's very little unowned land, right? That anybody want to inhabit, and you can't sort of like start up a new country someplace easily or something, right? So there's degrees to which, fair enough. The degrees to which Exot is possible in some spaces and not quite as possible in other spaces. But it's kind of funny. I think an aspect of Cirlo, where basically things sort of are under pressure, and then you expand into an open field, like the early days of Twitter, for instance, when people feel that they can kind of do what they want to do without impediments, without increasing Neaq, then they might not be as aggressive, I guess, in some ways. I don't know.
Another example might be like acquisitions, right? You see a newcomer entering in, rather than fight them, you just absorb them into the Borg, so to speak.
Yep. And it's interesting. That's one of the other. I haven't written this one up yet. A form called MOM, which is basically this thing of its digestion as well as acquisition. And it's kind of interesting about this because when we talk about the underlying systems behind these things and how real they must be, there's a story of Google basically going and buying Waze, right? And there's like this brilliant blog by the guy who founded Waze talking about how they were promised that they would be a separate company inside a company. But essentially, it's kind of like you're in a position where you can't form external relationships outside the company. So slowly you become absorbed. And it's kind of like the larger entity will basically take in. And it's
that's
kind of like,
happened to me. Yeah, they absorb a company and they digest its value with the aim of actually destroying it after they've absorbed all that value out. I think it's an actual technique. I think it's a strategy.
And the thing is, what's funny is we can talk about intentionality. I think the same dynamic would occur even if there was no intention. I think there's that same thing. And to me, it's striking that digestion and this kind of thing of acquisition and corporate, they have the same dynamics. It's just obvious to me that this is the same dynamic here. And I don't think there's any mistake or any accident, that these things are the same. So I don't think,
Yeah, you could scratch your head as to whether it's intentional or not, but at the end of the day, it doesn't really matter. And in a lot of ways, the end result is the same.
Yeah, definitely. Yeah. Chris basically mentioned, go ahead.
No, go ahead, Chris. I'm sorry, I was just going to make another point, but no, what did Chris mention?
Well, I'm just going to go and basically sort of share this little thing, if you don't mind for a second. I've got let's see, that's not what I wanted to share.
Okay. It's pretty though.
Oh, okay, there it is. Yeah, that's what I wanted to share. Okay. Yeah. Is it showing? Do you see a picture with it's all yellow?
Yes.
Yeah, it's the yellow one.
With like a leaf, yeah.
Very interesting because it's not showing when okay.
It's got a lot of the examples on there. Yep.
Yeah. So this is basically for Parzo, and basically I had this artist take some words that I had and basically go and put like an artistic form around these things. So it's kind of a fun thing. Yeah. I hope to make a book of this entire thing.
So the thing that interested me as well is you touched on scaling. And one of the things that I've been thinking a lot about, that Jeffrey West wrote a book called Scale. And since he wrote that book, he's been talking more and more about the fact that in these systems, the thing that scales most quickly and most often as you begin scaling an organization is inequality. And you can see it in your map of the train lines, right? Because as you begin to scale these different systems, you begin to privilege those points that have achieved scale, and and then the parts that are not as privileged become the distance of inequality becomes greater and greater. And I think that's something that often gets lost in the discussions about scale. That it's not just about scaling for size and scaling for this, it's also the distance that arises as we begin to scale things.
Definitely. And I think, this is, to me, almost an inevitable side effect of large systems, unless you do something drastic, right? That essentially, as you basically create systems which are aggregate upon themselves and increase value, and the value becomes concentrated, very much like the trunk of a tree in a way. And it's interesting because from the point of view of the system, it allows its persistence to some degree. I think this is where constructal law kind of ties in a way. It allows systems to persist that way. For us to have equitable systems as we grow them, I love the idea of kind of like doing things like having temporary leadership that's superseded by other leadership, and having hierarchies that rise and fall within an organization rather than being fixed. But we have to do special things to basically make those things happen. I think the thing I really like a lot better than that is like have lots of small systems instead of very big systems whenever possible. But then we get into the whole acquisition dynamic that we talked about a little bit earlier, because then you can have predation, where basically a bigger system acquires a smaller system and basically takes it on. So we kind of hope in the economy that there's enough disruption that basically larger enterprises fall and smaller ones can kind of start up, and then we have like an endless cycle with these things. So there's like an ecosystem to the entire system. But I do see that as well. I think that without any kind of overt action, you end up in situations where you're going to have like inequities across these things. It's just almost and people have done lots of experiments with like flat organizations, teal organization, stuff like that, and I think they're great. But I just love the idea of like keep it small, and then it's less of a concern, when possible.
Bruce mentioned in the chat the work of Aldous Krebs, who is awesome, and who, Bruce, if you ever can get him to come on here, it would be much appreciated. Side note. But yeah, I think it's not, I'm never looking for solutions. I just want to make sure that we keep these things in mind as we do all of these things, that it's more about recognizing the landscape that we're operating in and adjusting our thinking in those terms, rather than saying, well, we must solve this immediately, or it doesn't actually work like that, as we all know. When you're in this work, I think that's, if you approach it with a solution mindset, you've already lost the game.
I think particularly for people who want to change things socially within organizations and outside of organizations as well, it's kind of like being familiar with the dynamics enough to actually sort of like counter them when you want to is good, rather than just basically assuming that you can put something simple in place and those dynamics just simply won't occur if everybody's nice to each other, right? So I think there's that interesting thing of going and understanding the dynamics well enough to basically know when you need to go and take countervailing actions, and not pretending that the dynamics aren't there, because I think they're just pretty much endemic to the math of systems, and it's like, so I think that's the thing. People need to understand a bit about this. And Pareto was a bit of a shady character, because he took this stuff as normative rather than descriptive, and started saying, okay, it's inevitable that you're going to have these inequalities in society, and that's the way things are, and you can't do anything about them. And it's like, no, you described a default dynamic, and there's things you can do to basically mitigate these things, and that's good. But I think to the degree that we don't acknowledge them to be able to take counter actions, we're in trouble.
My bête noire. Okay, so before we wrap up, Michael Shoveldave, do you have anything you'd like to add to this conversation?
Yeah, I was just gonna.
I'm
Yeah,
randomly
no,
poking
I'm here.
people.
No, that's fine, Barbara. And sorry, I think you and or Bruce kind of teed me up, but I was distracted here off camera. But one thing, Michael, thanks for the talk. And there's just so much to absorb because I'm not read up and familiar with your work, but there's such a density of information you provided, especially with your unique terms. One thing that kind of caught me early in your talk when you introduced Postel's law.
Yeah.
And I think you introduced it through, and I don't know the origins of it, but it sounds like it came from communications theory.
Yeah.
Yeah. But then you extended it to social, maybe human systems. And one thing that popped into my mind is if it's applied efficiently and effectively really well in human systems, it seems like it might result in a potential narrowing and a significant reduction in variety, which could have adverse unintended consequences. So I'm just wondering if you've extended your thought or practice in social systems of when you want to relax or not pursue it, right? Because it seems that when if the output, or as you put it, be conservative on what you send, if that's applied within human systems, it seems like there could be a narrowing, diminishing, and you reduce variety, which will actually create highly risky situations. Right?
So I haven't thought about this deeply, but I think the degree to which there's a protective boundary around a social group allows you to go and basically sort of have the safe space, I guess, to use the terminology, to say whatever is on your mind and do those particular things, then kind of hope that you're able to resolve all the differences and at least coexist within the context of that space. So I think there is this degree to which social systems need protection from external threat to the degree to basically allow internal diversity in a sense. And, this protection doesn't have to be like a barrier as much as a set of, like rules, like Chatham House rules, for instance, or things along those lines that can basically sort of like serve that particular function. So I think that there's a natural segue that can happen in that space with these things. I think one other thing I would go and add is like, Postel's law came up in communications, network communications, but to me, I feel like that's not an invent, it's a discover, because essentially you're seeing the same idea from Marcus Aurelius and from people who basically are observing other kinds of systems as well. So I think there is this foundational aspect of some of these things, so thanks. Thanks for the question. And I think that's the area. So cool.
Okay, well, this has been great. I really enjoyed it, and really isn't that all that really matters. But I want to thank you, Michael, for hanging in there with us. You mentioned both Marcus Aurelius and Karl Popper. They're my guys. And so thanks again. And thank you to all of you for hanging in there with us. And Michael, please come back and we'll talk some more about all this stuff. It's been great. Thank you.
Thank you so much. Good deal.